Hi everybody. For the next little while I'm going to go over the kinds of questions that you would expect about circles on the final exam. This page might get a little bit crowded and I'll use some other paper on the side. Let's take off and see what comes. We're going to talk about a chord of length that is 7 from the center. And the distance from the center would have been measured perpendicularly. That length right there would be 7 in that figure. With a radius of 25, and you'd want to show a radius from the center of the circle to an end point of that chord, could have been B or A, forcing that one right there to be 25. And we're looking for the length of the chord. I would find this short distance first. Let me call that X. And I'm going to hit that with a Pythagorean Theorem and make quick work of that question. You should too. I think I already know the answer. Be careful who the hypotenuse is. The hypotenuse is the 25. 7 squared plus x squared is equal to 25 squared. That's one of those Pythagorean triples that would probably be pretty clever to have on your formula page. That's a 7, 24, 25 triangle. Because 49 plus x squared equaling to 625, that's 25 squared. Subtract 49 from both sides, you get x squared is equal to 576. Take the square root of both sides of that, and x would have been 24. However, be careful here. On the final exam, I would bet you a question answer alternative on this multiple choice test would be AB is of length 24. But AB is not 24. 24 is from the end point to the midpoint. So 24 and 24, the length of AB would have been 48. There might be another question like that. Let me just throw one to you. I'll toss one out. Say I've got a circle. And last time I gave the distance from the center. Let me just say I got a chord of length 20. That's how long that chord is right there. And the radius of the circle is, let's say 24. So how far from the center is that chord? If the chord is of length 20 and the radius, let me say the chord is of length 40. That way we'll use a 20 when we use the Pythagorean theorem here. The chord is of length 40 and a circle with radius of 24. How far is it from the center? Let's call that guy X and hit it with the Pythagorean theorem right quick. And what you would have to recognize is that length is 20, isn't it? If I make the full chord be 40. Therefore 20 squared plus x squared equals 24 squared. Let's see how this goes. We got 400 plus x squared equals 576. Subtract 400 from both sides, and we got x squared is equal to about 176. Take the square root of both sides of that. X will equal, and now that 176, that's 16 times 11. I'm pretty sure 16 times 10 would be 160, so that must be 16 times 11. Therefore, we say 4 square roots of 11, huh? That's how far it is from the center. Somebody asked me about this chord of length 40 in a circle of radius 24. I'll try not to get off track too much more. We'll stay to this page and work with those ideas. How to measure angles in circles. If the measure of angle C is 70, under the assumption that that's a central angle, and a central angle is the same as the arc it cuts, so I know that arc AB would have been 70, and that's asked of me. The measure of angle E. What kind of angle is angle E with its vertex on the circle? That's an inscribed angle. How do you measure it? An inscribed angle is 1/2 of the arc it cuts. Angle E, it's going to have to be half of that 70, it's going to be 35 degrees. And angle D, interestingly, these inscribed angles cut the same arc. They are necessarily congruent. Angle D is also 1/2 of that arc that they cut. Therefore, angle D is also 35. But you should remember inscribed angles that cut the same arc are congruent. More angles to measure. AD is 30 degrees. AB is 100. DC is 160. Oh, that's this one, isn't it? So we don't know the length of BC yet, but I think we can figure it out. I know the arcs of the circle add up to 360. Here I have 130 plus 160. That's 290. Take 290 out of that 360, leaving 70 degrees for this arc. I'm sure that was asked about. Yeah, arc BC is 70. How about angle 1? Not a central angle, not an inscribed angle. How do you measure an angle like that? Just somewhere inside the circle. You think that it has a vertical angle partner. You check out the arcs that they cut, and it is the average of the two arcs. I should add those arcs and divide by 2. So 70 plus 30, yeah, we'll write that out, but not 70 degrees plus 30 degrees divided by 2, that's 100 divided by 2. We're going to call that a 50-degree angle. That's angle 1. How about angle 2? Outside the circle. Different idea, but using just the arcs that it cuts. As angle 2 knifes through the circle, it cuts this arc of 30 and it cuts this arc of 70. And when an angle is outside the circle, you subtract the arcs and divide by 2. The measure of angle 2 would be the larger arc 70 minus the smaller arc 30 divided by 2. Giving us 40 over 2, yeah, measure angle 2 must be 20 degrees. Tx is tangent to circle Z, and Zx is 9. Lay that data in there, and Tx is 12. Give the length of Tz and Tq. First thing that comes to my mind as I'm looking at this is a tangent is perpendicular to the radius at the point of tangency. Therefore, this has to be a right angle right there, doesn't it? Then I'm going to hit it with the Pythagorean Theorem a little bit. I hope you already know the length of that hypotenuse when you set up 9 squared plus 12 squared equals, and wouldn't Tz be the hypotenuse opposite the right angle? Equals Tz squared. I'm thinking it's 15. But if you didn't know that, then come along, let's do this. 81 plus 144 is equal to Tz squared. And those add up to 225 equaling Tz squared. And you take the square root of that, and that's 15. So, let me label it that. Answer this question. Tz is 15. But it also asks me about Tq. And you're all clever and you can figure that out, I'm sure you can. But don't choke on this idea, because here's the thought. If this radius were 9, then this radius would have also been 9. The full length here is 15, that radius is 9, so the exterior part of that segment would have to have been 6, so they would add up to 15. Tq equals 6. Just using the idea that the radii are congruent. A few axioms that you'd want to know before you take that final exam, and truly that you should remember since you studied geometry. If an angle is inscribed in a semicircle, what must be true of that angle? Let me do that with a pencil. Maybe I can erase it and use that circle again. Let me show a diameter and inscribe an angle within that semicircle, like, say that. That's an angle that's inscribed in that semicircle. Not perfect, but there it is. What must be true? And you're saying, well, an angle that's inscribed in a semicircle must be an inscribed angle, and it cuts an arc of 180 degrees. Therefore, it's a right angle, isn't it? An angle inscribed in a semicircle is necessarily a right angle. And then the next idea. A central angle and an inscribed angle cut the same arc. What must be true? Wow, we just had one of those up here, huh? Where this central angle and these inscribed angles cut the same arc. And the generality here was the inscribed angle is 1/2 the measure of the central angle. The inscribed angle was half the arc, and the central angle is the same as the arc. So the inscribed angle is also 1/2 of the measure of the central angle. Two inscribed angles cut the same arc. Then what must be true? Yeah, we just talked about that one also, huh? What's true about this angle and that one? This angle and that angle, because they cut the same arc, are necessarily congruent. Inscribed angles cut the same arc are congruent. Let's play here. AT and AZ are tangent to circle C. A thing that is important, we would have to recognize that these two triangles are congruent. For interesting reasons, the radius matches the radius, and they both got this right angle, congruent to this right angle. And the hypotenuse of one is congruent to they have the same hypotenuse. So by hypotenuse leg, you got congruent triangles. And that's going to tell us some stuff. TZ is 120. The size of this arc from T to Z is 120, but I know that because these two triangles are congruent, these two central angles are congruent, therefore these two smaller arcs are congruent, each of them being 60. Half of that 120. It asks me to give the measure of angle 1. I think I would do better to get angle 2 first. Let me make a note about angle 2. It's a central angle. And the central angle is the same as the arc it cuts, and that cut an arc of 60 degrees. And I know that this is a right angle at Z. That's got to be true. That tells me a lot about angle 3, doesn't it? But because that's a right angle and this is a 60-degree angle, I know about angle 1. In this triangle, I got a 30, 60, 90 triangle, huh? The measure angle 1 must be 30. As we mark that tangent perpendicular to that radius, that also shows us that the measure of angle 3 is 90, doesn't it? Now, I'm not saying you're going to get a 30, 60, 90 on your final exam, but I am saying that you want to know that a tangent is perpendicular to the radius, and you can work through there, and you expect angles of a triangle to add up to 180. Let's play some more. About lengths inside of circles. AC and DE intersect at B. All right? And AB is 6. Let me put that one right there. And DB is 2. That length. BC is 6. BC is 6. Find the length of BE. Now, we could talk a long time about this and show why it's true, but the thing that you must remember is part times part of one chord is equal to part times part of the other. So in this case, let me call BE X. That's the thing I'm looking for, huh? In this first setup. And that would be 6 times 6 is equal to 2 times what we called X. So we got 36 is equal to 2X. I figure that X must have been 18, huh? And if that's all it asked me about, then I'll report that BE is 18. Now, I'm not sure I like what I did with this next question. I just looked at it a minute ago. But let's go see what I was up to here. I'll sketch it again. And I've changed a little bit here. It's still the same couple of chords, AC and DE, intersecting at B. However, we're going to let BE be 6 this time and find the length of BC. That's the unknown thing. But everything else I'm going to keep the same. Where AB was 6, I'm just trying to make sense of something I've written before. And DB was 2. So in this setup, can you find the length for BC? And I'm thinking, yeah, good. It's going to have to be 2. Why would that be true? Part times part equals part times part. Let me call that part X that I'm looking for right there. And 6 times X is equal to 6 times 2. Yeah, divide both sides by 6. I got X equal to 2. I'm not sure what I was thinking when I wrote that question, but there you have that. Give the equation of a circle with center at 4, -1, and radius 9. And the thing I'll need to have here, the thing I put on my formula page if I didn't have this built into my brain, is X minus H, quantity squared, plus Y minus K, quantity squared, equals R squared. Hey, mister, what's that? You say, well, that's the equation of a circle. And where's it centered then? And it centers at H comma K. I see the minus signs, but the center is at H comma K. The radius? Yep, we know about the radius too from this equation. It's R. Now we're going to write an equation here using these ideas. This must be X minus the X coordinate of the center, X minus 4, quantity squared, plus Y minus -1. I would expect that to be Y plus 1. Quantity squared equals, and then we're going to have a radius of 9, huh? And this shows us the radius squared, so I'd expect to see 81 there, or 9 squared. there's the good-looking equation of a circle whose center is at 4, negative 1 with a radius of 9. And then look at this. You remember one of these, been maybe a week or so. Let me set it up here. I'll need a lot more room. X squared plus, I'm going to put my x's with my x's and my y's with my y's. And if I bring that 10x to the other side, it's going to become a negative 10x. Going to leave a little blank right there. I'm going to complete the square. Plus, and then put my y guys with my y guys. I got y squared. These y's are already on the left-hand side, plus 6y. Plus, and I'm leaving another little blank, equals. And the constant on the right-hand side, I brought the 10x to the other side already, is negative 9. So here's our equation. I'll change colors. I'm going to put some special numbers right here. How do you find the number that goes right there so you can complete the square? Take 1/2 the coefficient of the linear term, therefore a negative 5, and square it. That would be a positive 25 right there. But if you add 25 to this side, better add 25 to that side. And do the same thing with y. 1/2 the coefficient of the linear term. This is the linear term. Half that coefficient is 3. We'll square that and get a 9. Add 9 to the other side. Then you say, well, what is this going to do for me? And that's a perfect square binomial, and so is this. And the stuff we got over here, well, that's just 25, isn't it? With a negative and a positive 9 adding up. And there's lots of ways to remember this, but if you could factor this, what would it look like? And it's a perfect square. The square root of x squared goes here, x, and the square root of 25 goes there, 5, and if this is negative, and it is, then this would be negative. Square root of y goes right there, and the square root of 9 goes right there. If this is positive, so is that. And I'm promising you multiply y plus 3 times y plus 3, you'll get this back again. So where's the center of this circle? And understand, the test would mess around with minus signs, so be careful. The center's at positive 5, negative 3. I expected minus signs there. When I get them, I'll report it as that value. When I don't get that minus sign, now see, it's minus a negative, that must have been a negative 3. Hey, what's the radius of your circle, mister? Yeah, that'd be 5. That's the square of the radius. Oh, we'll get the circumference and the area. And is it tangent to a circle, to an axis? We're talking about this circle right here, huh? With its center at 5, negative 3. 2, 3, 4, 5, 1, 2, 3. And a radius of 5. You see, would it be tangent to an axis? Since I went over 5 and its radius is 5, this won't be beautifully drawn, but it looks something like this, wouldn't it? It is tangent to the y-axis. There's a circle whose radius over 5, down 3, and a radius of 5. Yep. What's the circumference and what's the area? The circumference of that circle, since circumference is given by 2 times pi times the radius, the circumference of that circle would be 10 pi. After all, this radius was 5. And the area of that circle, since that's always given by pi r squared, the area of this circle would be